Welcome to College Algebra here at Northeastern Technical College. Today we're going to continue to review the intermediate algebra. So last time we talked about what a term is. Let me go back real quick. We talked about what a term is. We identify some terms, and then we solve some linear equations. We did some distribution, multiplying polynomials, including Fourier methods. We did spatial products, difference of square, and perfect square binomial. We reviewed factoring greatest common factors. We did factoring by grouping, factoring trinomials, factoring the spatial products, okay, difference of square, and I think we just did that one, difference of squares. And then we wrap it up on our last video with solving quadratic equation by factoring. Alright, so in this video we're going to continue our review, and objective number 11 and on are the intermediate algebra materials. So rational expression is just an expression consists of polynomials on the numerator and denominator. To multiply rational expression, what we want to do is first by factoring, and then we're going to reduce top with the bottom. Currently, if you look at this rational expression, I got three terms on the top and bottom for both fractions. If I got three terms over three terms, I cannot just go ahead and cancel them out, top and bottom. We cannot reduce top with the bottom unless it is one term on top over one term in the bottom. So factoring allows me to make my polynomial top and bottom into one term. So let's factor our trinomial up here. For x squared, we can use x and x. Alright, factor of 7 got to be 1 and 7. Since the last term of the trinomial is positive, that tells me the choices inside the parenthesis got to be either positive or negative. Since my middle term is negative, that means I need to have a -7 on the outer and a -1 in the inner. So when you combine -7 and -1, you get -8. Alright, denominator, x and x. Factor of 4. Here I'm not going to use 2 and 2 because I know 2 and 2 is not going to combine give me a 3, so I will use 1 and 4. Since my last sign is negative, it tells me that my inner and outer got to be subtract to get my 3 in the middle. It also tells me the choice for the sign is 1 positive, 1 negative. Since I need a positive 3 in the middle, I will need to have a positive 4 on the outer, -1 in the inner. Alright, this one, the top one again, x squared will be x and x. Factor of 10, I would use 2 and 5 right away. Since the last one is negative, I got to subtract my inner and outer to get my positive 3. So I need to have a positive 5 on the outer, -2 in the inner. Denominator, x and x. 14, 2 and 7. Since my last sign is positive, the choice for the sign is positive or negative. Since the last sign is positive, my inner and outer got to be added to get that 9. Since my middle term is negative, both of them, inner and outer, got to be negative. Alright, so after I factor, everybody is one term top and bottom, so I can reduce top with the bottom. The x minus 1 can be cancelled out. Minus 7 can be cancelled out. Minus 2 can be cancelled out. So the only thing I got left on the top will be my x plus 5 over denominator x plus 4. Alright, so the point here is for us to reduce the numerator with the denominator. The numerator and the denominator got to be one term over one term before I can cancel them out. Alright, division of a fraction means times the reciprocal. So I'm going to flip my second fraction here in the minutes. So what I'm going to do here is same thing as the previous problem. I'm gonna factor, and at the same time I'm gonna times the reciprocal back here. So I'm gonna go ahead and say times the reciprocal. Alright, 2x squared. Let's factor, make them all one term first. I'm gonna write this on the side right here for you. Alright, for 2, factor of my first term, that will be x and 2x, or 1 and 2. For 20, the first thing comes to my mind is 4 and 5. Can't put the 4 with the 2x, that will cause a greatest common factor. So I'm going to put 4 right here, 5 right here. Right now my outer is 5, my inner is 8. 5 and 8 combined will give me a 3 in the middle if I subtract. So the last sign tells me how the inner and outer is gonna get to the middle term. Since my middle term is a negative 3, alright, the last sign also tells me the choice for the sign is positive or negative. Because the middle term is negative, I got to give my negative to the higher of the two inner and outer. So when I combine these, I get negative 3 in the middle. So since I know my outer got to be positive 5, that would be x times positive 5. The other one got to be negative. So I'm going to write it back here. Alright, so I'm going through the trinomial process, okay? Normally I just begin to do it quicker and quicker. So I just want to write this example for you on the side, but the next three I'm going to just do it from the problem. Alright, again, x and 2x. And in my mind I'm thinking, okay, what times what is 30 right now? Normally I would do 6 and 5 first. And I know 6 cannot go with the 2x. So 6 go here, 5 go here. Let's see if it will work. My outer is 5. My inner is 12. 12 and 5 subtracted will be 7. Since I need to get a negative 7, I got to have a negative 12, positive 5 on the outer. Alright, times the reciprocal. So that means this denominator in the original problem will flip to the top. So let's factor this denominator here. For 4x squared, here I'm going to use 2x and 2x. 9 will be 3 and 3. Okay, my outer is 6, my inner is 6. That combined will be positive. Okay, since my positive 12. Since my last sign is positive, I will add my inner and outer, or my two signs will be the same. Alright, this numerator come to the bottom, so let's see. X and 2x. 12. 4 times 3. I'm going to put 4 right here. 3 right here, because 4 cannot go with the 2x. That gives you another greatest common factor that you don't have. Outer is 3, inner is 8. 3 and 8 subtract. The last sign tells you to subtract to get my middle term. To get a negative 5 in the middle, I got to have a negative 8 and a positive 3 on the outer. Negative 8 for the inner, positive 3 for the outer. That looks nicely. Alright, so everybody is one term now, top and bottom. So the x minus 4 cancels out. 2x plus 5 cancels out. One of the 2x plus 3 up on the top and the bottom cancels out. So only thing I got left on the top, 2x plus 3 over denominator, only thing left, x minus 6. I'm going to show you how to add a rational expression. Addition and subtraction of rational expression is the same. I only has a addition problem. So when we add fraction, the first thing we got to do is find the least common denominator. Alright, so what we want to do first is to factor, okay, your denominator. Factor the denominator. The x squared minus 1, if you recall, this is a difference of squares, because subtraction sign with both terms are perfectly squared. So that will give me x plus 1, x minus 1. Alright, the x squared plus 2x plus 1, that would be x and x. This is a trinomial, so that would be x and x, 1 and 1. And I believe you can see both the sign got to be positive. So when we're looking for LCD, what you want to do is factor your denominator first, write them in factor form, and then count the repeated factor between the two denominators, and also count the non-repeated factor. Apparently the x plus 1 repeated between two denominators, so we count that one time. The x minus 1 did not repeat with the other denominator, so we count that one time. So is the x plus 1 did not repeat, so we count that one time. So your LCD is x plus 1 times x minus 1. Alright, normally once I find the LCD between the two rational expression here, I will just write them as one big denominator. I'm not going to write it as 2, it's too much work. Alright, so most of the time here we will say x squared minus 1 will go into your LCD so many times. Alright, that's kind of hard to do, so I'm gonna say it a little bit differently. The way I'm saying it is, what does the LCD has? Look at the LCD. What does your LCD has that the first denominator do not have? The first denominator compared with the LCD is missing an x plus 1. So that's how many times we're going to increase. So since the first denominator is missing a x plus 1, so we take that times my numerator 3. Alright, plus 2x times. What does the LCD has? That the second denominator do not have. Second denominator is missing an x minus 1. So that's how many times my second denominator will go into the LCD. X minus 1 times. Alright, so now I'm just gonna simplify my numerator. Alright. Let me write it out. Alright. Addition sign outside the parenthesis tell me I got two terms. What's in front of it is one term. This is my second term. Alright, so 3 times x, 3 times positive 1. That will give me 3x, positive 3. My second term, do a distribution. 2x times x, 2x squared. 2x times -1, -2x. Combine like terms, I get 2x squared plus x plus 3. Alright. Now, normally, this answer I will factor again to see if the factor can be reduced with a denominator. And I don't think I can factor this numerator. Alright, it's not factorable. So my final answer, 2x squared plus x plus 3 over x plus 1, x plus 1, and x minus 1. Alright, that'll be my answer. I want to show you an example of subtraction, but this one looked a little bit different. Okay, let me show y'all something real cool. Before I show you how to do this problem, I want to show you this concept, something you learned a long time ago, a mixed number. For example, if I have a 2 and 3 over 4, a mixed number is basically a whole number plus a fraction. It's not times a fraction, it's a whole number plus a fraction. So that means a mixed number can be written as 2 plus 3/4 here. Now thinking back, to convert a mixed number into improper fraction, we normally take the denominator times the whole number. That will give me an 8. Then we will add on to the numerator. And the reason why we add to the numerator is because there is supposed to be a plus sign right here between the whole and the fraction. So 4 times 2 is 8 plus 3. That will be 11 over 4. So that means whenever we are combining a whole number with a fraction, we can use the same trick. Denominator times a whole number, 4 times 2 is 8, then plus the 3. That will give me the same thing. Alright, so we're going to use the same technique over here. This is subtraction between a whole number and a rational expression. So what I'm going to do is take my denominator, x minus 4, times my whole number, x minus 4 times 3. That will be 3 times x minus 4. Then what do I do with the 10 on top? We will subtract, because it says subtract, over denominator, still the same thing, x minus 4. Alright, this is one technique. Okay, this is one of the many techniques you can do this problem. The reason why I put x minus 4 in a parenthesis, okay, here is because x minus 4 is 2 terms represent one denominator. So when I have multiple terms representing one thing, I always put them in the parenthesis. Alright, so let's do some distribution here, and I'm going to go ahead and do this slightly quicker. 3 times x is 3x. 3 times -4 is -12. -12 minus 10, -22 over x minus 4. Top and bottom cannot be factored. Alright, so this is my answer. Alright. I will do something look like this later on the semester. And one thing I want to review with you, we use this. We're gonna use this pretty quickly. Is your radical expression? Simplifying your radical expression. Radical expression can be square roots, cube root, fourth root, and so on. Okay. Since the 18 here is not a perfect square, then we got to kind of break this thing down a little bit, okay, before we can simplify it. You've probably done this in Algebra 2 class before. there are different ways to break down the 18. So as far as right now, I'm gonna just kind of show you the way I normally show my students in the intermediate algebra class. So basically, I'm looking at this 18. I'm gonna think of a prime numbers that will go into 18. So that can be 2 or 3. I'm gonna use 2 first. I'm not gonna use a 6. 6 is not a prime number. 2 will go into 18 9 times. And I'll break down my 9 using the prime number 3. 3 go into 9 3 times. So this 3 down here is a prime number, so the only 3 can go into 3 1 time. So when I see this 1, okay, that's when I stop. So the 18 is made out of 2 times 3 times 3. To get out of a square root, you got to have 2 of the same number to go out as 1. So these 2 3s will come out of the square root as 1 3. Alright, the 2 here cannot come out because it's only got 1 of them, so that stays inside the square roots. So my answer, 3 times square root of 2. Doesn't matter which method you do this. The bottom line, I need y'all to know this is 3 times square root of 2 right away. Alright, this is a very interesting problem. Cannot have a negative inside the square roots. So when you see that, you know your answer will be imaginary. I still need to break down the 24 though. 24. Probably 2 times square root of 6. So if I break this down on the side here using prime number 2, that will be 12. Using 2 again, 6. And I know 6 is only made out of 1 2 and 1 3. So that means these 2 2's will go outside the square root as 1. This 1 2 and this 1 3 got to stay inside. So when they stay inside, they multiply, it becomes a 6. And remember, square root of a negative will give me my I. Alright, so my answer, 2 times square root of 6i. Another thing that we're going to do in this class is called the rationalize the denominator. It turns out we cannot have a radical in the denominator. Okay, square root cannot be in the denominator due to the a plus bi form, the complex number form. So I'm going to get rid of the square root down here in the bottom. So the way we do it, alright, is look at the 3 inside the square root. I already have 1 3 here. To go outside the square root, I need to have 2 of them. I need to have 2 3s to go outside as 1. So that means I only need 1 more square root of 3. So I will multiply a square root of 3 over square root of 3, because this is still equivalent of being a 1. Okay, so that's legit. This is a 1, so I'm allowed to multiply the same thing top and bottom. Alright, so right now in the denominator, I have a square root of 3 times square root of 3. Okay. So since the 2 radicals are the same roots, I'm allowed to put the 2 3, okay, inside the same radical. So that will give me square root of 3 squared. Alright, since square and square root will cancel out, the only thing I have left for my bottom here would just be a 3. Because the square root got canceled out. And that's the whole purpose of multiplying along the square root of 3. So when you have 2 of them, it can cancel out with the square root. Alright, 4 times square root of 3, still 4 times square root of 3. So that's my answer. And remember, what's inside the radical cannot cancel out with what's on the outside. Okay, so this whole thing is your answer. Let's try another one. I already got 1 5 here inside of my radical, so all I need is another one. So I multiply another square root of 5 over 5. So square root of 5 times square root of 5. Okay, you can write them out this way like I did on the top, or you can say, oh, that will be square root of 25, which is 5. Either way will work. Bottom line is you need to know the radical will cancel out, so the bottom have no more square root. 5 times square root of 5 is 5 times square root of 5. I got 5 on top, 5 in the bottom on the outside, so that can be canceled out. So the only thing I got is just square root of 5. Alright, I'm going to wrap it up this review with solving quadratic equation. The one that we did on the previous lecture video, that was solving quadratic equation by factoring. Alright, there are many ways to solve quadratic equation. We can do it by factoring. Alright, if the problem is factorable. If it's not factorable, we can actually do it by what we so-call the square root product, square root property. Do it by square root property. Or we can do it by, you might remember this, the quadratic formula. Okay, we can do it by quadratic formula. The square root property is designed for your quadratic equation consists of 2 terms, just like this example. This problem only got 2 terms. And you know t squared plus 27 cannot be factored. Alright, so this is how you work with the square root property. Isolate your square terms by moving the 27 over to the other side. So I got t squared equal to negative 27. Alright, to get t by itself, okay, we will take a square root on both sides, because square and square root will cancel out. When I take a square root on my right hand side, I will put the entire negative 27 inside the square root. Square and square root canceled out, my answer t equals, and when I take a square root on both sides, my answer will always be a positive and a negative. Do not forget, your answer will always be a positive and a negative. Alright, break down the 27. Simplify the 27. Square root of 27, it should be 3 times square root of 3. Square root of a negative should just be an I on the outside the radical. So that's my answer. 3 times square root of 3i, or negative 3 times square root of 3i. You always get 2 answers. Okay. Now, if my quadratic equation has 2 terms, I use a square root property that will get my answer quick. Now, if my quadratic equation is in the trinomial form, and this problem cannot be factored, I can use quadratic formula. And as you can recall, quadratic formula will be negative b plus minus square root of b squared minus 4ac whole thing over 2a. Alright, so my a, b, and c are simply my coefficients. So my a is 1, right? I wrote this down for you before. The trinomial form, ax squared plus bx plus c. I don't know if y'all remember that or not. There you go. So a is 1, b is 6. Be careful now. If it's got negative here, be careful with your signs. C is 13. So this problem is not factorable, so we turn to quadratic formula. So that will be negative b, that will be negative 6 plus minus square root of b squared. So I'm going to write my 6 inside the parenthesis, whole thing squared, minus 4 times my a times my c, and the whole entire thing over 2 times my a. Remember, there's 2 terms on the top. Both terms share the same denominator. So I drew my fraction bar long because it's covering for both terms. Now once you write it out, the next thing you do is type in what's inside the square root in the calculator. Okay, see what that number come out to be. I'm not going to type in a square root. I'm just going to type in what's inside the square root. Parentheses 6 raising to the second power minus 4 times 1. Move over here a little bit. Times 13. So inside the square root is negative 16. So negative 6 plus minus square root of negative 16, whole thing over 2. Alright, so I know square root of 16 is a 4. Square root of a negative is an I, whole thing over 2. Alright, when the numbers on the outside the square root, all 3 of them, got to be all 3 of them. If they can be reduced, you reduce them. Okay, if it is 2 of them can be reduced, you don't. You got to be all 3 of them on the outside reduced. So my answer, negative 3 plus minus 2i. So that means my solution is negative 3 minus 2i, comma, negative 3 plus 2i. Okay, my answer is in complex number form, a plus bi form. Okay, get 2 answers. So my answers are complex number, or most students call it imaginary. Alright, so these will be the topics that we will go over in this class. We'll do a lot of these arithmetic as we go along this semester. Alright, and I hope the review will help you greatly throughout the semester. Alright, thank you for watching.